All right, so welcome to 9.2, scientific notation. Scientific notation is a way to write really big numbers like the size of asteroids or really small numbers like the size of atoms or bacteria in a way that you don't have to write lots and lots of zeros. All right, so 8.2 times 1,000. Now, you could sit there and actually do that. But when you multiply by 10, you move the decimal once. When you multiply by 100, you move the decimal twice. And when you multiply by 1,000, you move the decimal 3 times. So 8.2 times 1,000 is what? Well, 8.2 times 1,000, there's 2 empty spaces I just put there. And so it is, and commas for numbers over 999. And so we have 8,200. So number 2 is scientific notation. That's what it looks like. And you should be able to tell me how much that is, because 10 cubed is 10 times 10 times 10, which is 1,000. So it's the same problem as number 1. And the fact is, there's a shortcut. You could turn this into, by moving it 1, 2, 3. Same shortcut. If you multiply by 1,000, you move the decimal 3 times. You fill in the zeros that are in the empty spaces. Right? Notice, by the way, it's a 3 for the exponent, but there's only 2 zeros there. And that's not a pattern either. Right? It's how many times you move the decimal point. Okay, so 3 times 100th, well, if you could put it over 1, you'd multiply the top, numerators. 3 times 1 is 3, 1 times 100 is 300ths. Okay, so then what the heck is number 4? Well, it's the same as number 3. That's 10 to the negative second is 100th. We just showed that. So that is also 300ths. Now, we will be writing our answers today, though, in decimal. So write 300ths as a decimal. Right? Hopefully you're all writing 0.03. Right? And so it turns out 3 times 10 to the negative second power is 0.03. And it turns out when you have 10 to the negative second power, right? When it was third power, you moved it 3 times and make it bigger. When it's 10 to the negative second power, you move it 2 times and make it smaller. Right? You move it 2 times and make it smaller. 10 to the fourth power, so 10 cubed, we said it was 1,000. So this is 1,000 times 10, which is 10,000. So what's 10 to the negative fifth? Well, 10 to the fifth multiplied by 10 again, you get 100,000. So 10 to the negative fifth is 1 over 100,000. It's the reciprocal. Negative exponents make reciprocals, right? They make reciprocals, not negative numbers. All right, so let's look at this 2 numbers, right? What is that number in blue? Well, these are the thousands, these are the millions, these are the billions, these are the trillions. That's 582 quadrillion. And if you had to write 582 quadrillion, maybe you wouldn't want to write all those zeros. So what you write is 5.82. You can't write 582. You have to write 5.82, and you'll find out why in a second. And then it's not 17 zeros. It's how many times I had to move the decimal point. 3, 6, 9, 12, 15 zeros in this one, 16, 17. It's 10 to the 17th. I had to move that decimal point from where it started in 582 quadrillion to 5.82. And that way you get to get rid of all those zeros. What if you had 19 over a billion? That's what that is, 19 billionths. How could you write that? Well, as a decimal, the billion, right? We go tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millions, 100 millions. This is the billionths place, and that is 19 billionths. And notice, once again, there are not 9 zeros there, okay? There are in that one, but don't do that. 1, 2, 3, 4, 5, 6, whoops. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh, did I write this wrong? 6. 1, 2, 3, 4, 5, 6, 7, 8. And so it should have been 1.9 times 10 to the negative 8th. Yuck. All right. All right. So scientific notation is not hard, but it has a lot of rules. And here they are. All right. So the number always is multiplied by a power of 10, as in 10 squared, 10 to the second, or 10 to the fifth. Okay? And the decimal point, this is the key one, the decimal point is always after the first digit. So what of those numbers is not in scientific notation? Copy the one that is, right? There's the one with the decimal after the first digit. It will always start with 1 through 9, always. All right? It cannot start with 41 because the decimal point's in the wrong spot. It has to be after the first digit, the 4. So that can never be an answer. Same thing here. Which one has decimal in the right spot? The first one. It can't be in front either. All right? Either way, it's 1 through 9, then maybe there's more stuff. One of those is correct. It's not this one. We didn't write the decimal because we don't write 6 point, right? And we're trying not to write zeros with this, so we don't want to write 6.0. So this is in scientific notation, 6 times 10 to the 8th. 9 times 10 to the negative 4th is correct. This one's wrong for 2 reasons. One, it can't start with 10. Second, it has to be times 10 to some power. All right, that's a 9. That's a power of 9. So the correct one is this one. The decimal point is right there. So when they have a negative exponent, they're making fractions, small numbers. When they have a positive small number exponent, then you're making big numbers. All right, so we're going to turn that number, hopefully you know what that number is, it's 145,000, into scientific notation. So it's always blank times 10 to the blank. So now what you do is you get rid of the zeros, you write the numbers that are not zeros, and you put the decimal right after the first digit, so it's 1.45. Then you count from the end how many times you moved the decimal. 1, 2, 3, 4, 5. And so this is 1.45 times 10 to the 5th. Right, that's how you write 145,000 in scientific notation. Now, you can get rid of these zeros on the end, but you can't get rid of what's called a trap zero. So it's the same game, blank times 10 to the blank. So we're going to write 207 and put the decimal right after the 2. So how many times did we move the decimal point from the end? 1, 2, 3, 4. So it's 2.07 times 10 to the 4th. That's how you write 20,700. The distance around the Earth at the equator is approximately 40 million meters. Write the distance in scientific notation. So get rid of all those zeros. We write 4, right? We don't have to write 4 point. 4 times 10, and it was 1, 2, 3, 4, 5, 6, 7. Now, that one, the number of zeros matched, but that is not the rule, right? Right? It's the number of moves, right? It was 5 moves there, not 3. It was 4 moves, not 2. Right? And it's got to go behind the first digit. It will always start with the number 1 through 9. All right, so those were big numbers, now small numbers. So that's a small number, right? So it's the same game. You get rid of the zeros, put the decimal behind the first digit, and then how many moves was it? 1, 2, 3, 4, but this has got to be negative 4. All right, and I wouldn't memorize things by left or right, but you should memorize that small numbers like that have to have negative exponents. What is that number? Well, that's 58, not out of 10 or 100 or 1,000 or 10,000. It's 58 out of 100,000. 58 hundred-thousandths. Same thing. Can't get rid of trap zeros, so we put 0607, put the decimal behind the 6. It's always times 10. How many times do we move it? 1, 2, 3 to get behind the 6. Make sure you go past the first non-zero digit. And so 10 to the negative 3rd, right? That's 607 as a fraction, not over 10 or 100 or 1,000 or 10,000, 607. That's another 100,000ths. Yeah, notice that they both end 5 places over in the 100,000ths place. So this is what it's used for. And notice how hard that is to read without the commas in it. That's why commas are so helpful in big numbers. In small numbers, we don't put them, tradition. So we're going to get rid of all those. We're going to write 5 times 10. And we had to go 1, 2, 3, 4, 5, 6, 7 to get behind it. And since this is a word problem, we're going to actually put a word on it. Meters. 5 times 10 to the negative 7th meters. And by the way, we don't tend to say negative cubed or negative squared. We just say negative 3rd power, negative 2nd power. All right, so now we're going to go back to regular numbers. So what number is that? All right. we're not going to add 6 zeros. We're going to move the decimal 6 times. So if we move the decimal 6 times, think about how many zeros we have to add to fill in the empty spaces. Hopefully you're putting 4 zeros this time. And then I want commas in the right place. So 1, 2, 3, comma, 1, 2, 3, comma. You should be able to say that number out loud. That is 7,170,000. All right, so where is the decimal point to start? It's there, right? It's behind the 2. And so we got to move it 5 times. So this time we are adding 5 zeros. And we're putting the comma in the right spot every third. And that 2 times 10 to the 5th is 200,000. All right, so negative exponent means this is a small number, right? We're going the way that makes small numbers. If you go the other way, you're going to get 2,600. That's not small. We need small, right? So we have 2 empty spaces. 0.0026 is the 2.6 times 10 to the negative third. That's 26 over 10,000, 26 10,000ths. Where's the decimal point? It's behind the 7. We got to move it 4 times. That means we're adding 3 zeros, and that is 7 10,000ths, right? Tenths, hundredths, thousandths, 10,000. That's 7 10,000ths. The other one ended in the exact same spot. That's 26 10,000ths. All right, so it's part of the standard that you know how to read this if you see it on a calculator. So a lot of calculators, I encourage you to do this. Take 2 really big numbers and multiply them. And a cheap calculator will start flashing error. All right. A good calculator will try to tell you the answer even if it doesn't have enough room. And what good calculators do is they find some way to clue you in to the answer in scientific notation. So if you saw that on a calculator, it's E for exponent. That's 3.8 times 10 to the 4th. Take a calculator tonight, multiply some really huge numbers, and see what happens. All right. So what's that? That's a really small number. That's saying times 10 to the negative 6th. All right, so there's a great shortcut to tell which of these is larger. The one with the bigger exponent is bigger. That's bigger. This whole number is bigger. Don't even look at the 2.3. You would look there to break a tie. If we had a tie in exponents, that would break the tie, but that's it, right? Think about this. There you're multiplying, that's not times 10, 100. You're multiplying by 10,000. But over here, there's 2 more zeros. You're multiplying by 1,000,000. So here we have 2.3 times 10,000. Here we have 2.3 times 1,000,000. This has to be way bigger. Now, so you just look at the exponents. All you got to do. Now you could sit there and move the decimal point 6 times and get 5 zeros. 3, 4, 5. And you'd realize that 2.3 times 1,000,000 is 2,300,000. And this one you'd move 4 times, and you have 3 zeros. And that's only 23,000. This is the way bigger number. Okay, let's see if we understood. Right? This one is way bigger because 6 is bigger than 2. This is only 990. We would never write that in scientific notation. This, move it the decimal 6 times, you get 5 zeros. 1, 2, 3, 4, 5. We come back. That's 4,400,000. Okay, now, what's bigger, negative 4 or negative 6? Hopefully everyone is saying that negative 4 is bigger. So this is the bigger number, right? Because you move that 4 times, you get 3 zeros. All right, so that's 17 over 100,000. But you move, which is small, but this is even smaller. You move that 6 times, you're going to get 5 zeros. This is even smaller, right? Negative 4 is bigger than negative 6. Therefore, 1.7 times 10 to the negative 4th is bigger. Right? Negative 2 is way bigger than negative 6. All right, let's practice all this. So let's make sure you can write all these numbers. So that's 3 times 10 to the 6th. That's 3 million. That's 9 times 10 to the negative 4. You got to get behind the 9. you move this 7 times. In this case, you get 7 zeros. 1, 2, 3, 4, 5, 6, 7. And then you write, that is 50 million. Here, we're going 4 this way. 1, 2, 3, 4. So we have 3 zeros. And we get 8 over 10,000. 8 10,000s. All right, but careful. All right. This had 7 zeros because there was nothing behind the 5. That's the only reason. Right? I have 5.2 here, you'd have 6 zeros. I have 5.21, you'd have 5 zeros. All right, which one's the largest? It's not even close. It's that one, because -2 is bigger than -4, which is bigger than -6. All right, good luck on the homework.